is the start of our CISPA European Championship with the local round here in Vienna. So thank you all of you for coming. We know this is a weekend. You normally would be at home and relaxing, but you are here to be with us and work on these challenges. So first of all, we'll introduce ourselves, so a bit about who is behind this European Championship. So we are really researchers who travel the world to work on the AI, especially the edge of this research. So my name is Adam Dziedzic, and I literally traveled the world. I worked at Google, Microsoft. I also was at Chicago in the US, you name it. And then the same is about Franziska.
Yeah, I'm Franziska Böhnisch, and like Adam, I'm a faculty at CISPA. And before, I was a postdoc in Toronto and got my PhD from Berlin. And I also had a lot of research stays everywhere, and that's where I got really excited on these topics that we're looking into today, the intersection of security and AI. And we're not alone here, and this hackathon would not be possible without our great team. So lots of our PhD students and master students are here today because they contributed to the task, because this is based on their research, and they will be here also to assist you if you have any questions during the day. And we all are currently in CISPA, and just if you haven't heard about it yet, CISPA is a research center in Saarbrücken. This is basically located between Frankfurt and Paris at the French border. And we are extremely proud to have such a diverse community over there, from researchers from all over the world, and with lots of faculty working on different topics, both from core security, core ML, and the intersection. And as you can see, we are very international, with like people from more than 50 different nations. So one thing that we are also particularly proud at CISPA, and this is also where this idea of the hackathon was born at, is that we do a fairly good job in research, especially at this intersection, especially at cybersecurity, because if you look at CS Ranking, which is the portal that ranks research institutions worldwide based on their research output, you can see that CISPA is at the first place worldwide for cybersecurity. So obviously, if you have any questions about also opportunities later on, we have our science and support team and our applications team here. So like you have Peter there, Pauline and Lena, and you can just talk to them if you think that is interesting for you to learn more about the Institute and what you could do over there. And while we are on it, I would also kindly like you to follow us on social media, because our social media experts here, like in the back, David and Felix, they're going to post about the event during the whole day. And so if you find yourself, you can just repost, and you can just like and share, basically, to make people excited about what we are doing, because this is what the event is actually all about, to get people excited about this topic of AI and cybersecurity. And just like a short intro into our group, you have seen already some of the faces, but actually we have more PhD students in our lab who have also contributed to producing the task for today, and who work on the research with us. Adam and I co-lead the so-called SprintML-Lab at CISPA, and we work on all aspects on security, privacy, robustness, interpretability, and overall trustworthiness. And if you want to find out more about this line of work, then also you can visit our website. And today, we're actually at the second local hub of our CISPA European AI and Cybersecurity Hackathon Championship. What it means is that it's the second time that people come together and solve tasks from our research. And those who will be doing well today, so the first 3 teams, will be invited to join us for the grand final in July at CISPA. So if you're onto the challenge and you do very well today, then you'll be visiting us at CISPA in July, and you compete for the prizes of the grand final, where the first teams get 4,000, 2,000, 1,200 euros respectively, and all the teams who qualify eventually get 400 euros, and the travel expenses to CISPA paid. So I think it's a great opportunity to become the European champion in AI and cybersecurity. And just a short overview on what we're expecting today. So we'll now tell you about our kickoff and the information that you need to solve the scientific challenges of the day. Then we'll start a hackathon, and we first of all give you some short introduction of how to use the compute infrastructure. Then you can start hacking. At some point we're going to have dinner, and then afterwards the building is basically for you to use the whole night to work on the challenges. And then tomorrow morning we're also going to have breakfast. And after 24 hours in, we're going to stop, and then eventually the teams will be evaluated. And you will be competing in 3 tasks, and the people who do best on the average of the 3 tasks, the best 6 teams, will be presenting their solution, and then a jury will be assessing their solutions. And basically the assessment from the jury counts as a 4th task, so it can still change the final ranking. So also when you have some solutions, just make sure that they're creative and innovative and something that you'll be proud of to present eventually. And eventually we'll have the award ceremony where we give the awards out to the first 3 teams. And if you haven't done so yet, please join our Discord channel. It's on Discord that we'll be sharing all the information. It's on Discord that you can reach out to us very easily. If you need help for any task, you'll just text us there. If something isn't working for you, we can help you there. So everything basically is going to be on Discord. And we'll be presenting now some technical things, and if during the hackathon you have some questions about that, we have our 2 master brains behind the whole scoreboard infrastructure and the evaluation, which is Nima and Aditya. So please feel free to reach out to them. And this is how the leaderboard is going to look like. So you already see we'll have 3 different tasks and an overall ranking. And so you can live see how your solution performs. And what the evaluation is is that during the hackathon we have a validation set of 30% of the data. So your score that is displayed during the hackathon is going to be on 30% of the final data. And this gives you a good estimate where you're ranking. And then the final evaluation, so your final ranking, is determined on the other 70% of the data. So you won't get an advantage from overfitting your solution to the particular data points. But you want to make sure to have a solution that generalizes well. And this 30-70 split is the same for all, and it's the same during the whole hackathon. So yeah, just use the scoreboard as a rough guidance on where you're currently standing. And now comes the most exciting part, the task that you're going to be solving today. So overall, in every of the local hackathons, we have 3 tasks. And the first task is about dataset inference. So we're going to talk more in detail about the task and the evaluation metric, but just a short notice. The dataset inference is determining whether a particular data subset was used to train a model. The next task is about text attribution. So we'll be giving you lots of texts that are generated by different language models or by humans, and your task is to find out which model generated which text. And finally, the last task is about watermark removal. So watermarks are indistinguishable usually in images embedded to mark ownership, and we put you in the shoes of an adversary who would like to use the images without attribution and therefore reduce the watermark. And
so important part actually is that we have to also measure how you perform on these tasks. So we'll use this main metrics. This is actually introduction to overall fundamentals to understand how we evaluate each task. So this is kind of overview. So very simple example just to give you understanding of this basic stuff. So we have positives. So you can think about this as being, for example, class cats. So you have this blue box with the positive samples. Also you have this light blue box with the negative samples. You can think about it as being, for example, classes of dogs. And then comes your part. So you have to classify which of these points are positive, meaning in this case cats, versus the negatives, in this case being dogs. So you set up this decision boundary, here being this black oval, and actually this is how you classified this example. So you say that everything inside the oval in this green and red part actually, according to our evaluation, would be positive. So it would be, in this case, class cat. So as you see here, we didn't perform that well. You have only true positives twice, so truly the samples that actually were, in this case, positives, and you classified them as being positive, and you also had two false positives, meaning classes that actually were misclassified. So important metric is precision. So we take into account all your evaluations, all your guesses for the positive samples, and you compute precision, which is true positive numbers over true positive plus false positive. Second important metric is recall. So here we focus on this dark blue part, which is all the positive samples, and we evaluate how many of them were true positives versus false negatives. So the recall is true positive over all positive samples, which is true positive plus false negative, and actually it's also called true positive rate. And finally, we focus on the light blue part, which is all the negative samples, and here we compute this false positive rate, in short abbreviated as FPR, which is FP over all negative samples, or FP over FP, so false positives plus true negatives. So these are metrics that actually we'll be using again and again. So it's great if you could just remember this basic visualization, and we will go over specific metrics per task very soon.
Then let's come to the first task now. And we also plotted here the people in from our team who are the expert on this task, because they have done significant amounts of research. So if you have particular questions, those are the people to turn to. And so let's start from a short intro. Maybe most of you have heard about membership inference attacks so far. Membership inference attacks ask the questions that you have a trained machine learning model and the data point. And now you want to know, has this data point been used to train the model? And what you can do, for example, is you query the model, and then you get the logits, some confidence scores, and you use that to determine the membership. Now, membership inference attacks are not usually very confident, especially in large models, so often they don't perform better than random guessing. That's why people have moved, especially to larger models, for so-called dataset inference. And in dataset inference, you don't ask the question about a single data point, but you ask the question about a whole data subset. So you want to know, was this data subset used to train the model? And so basically here, we showed that the dataset inference doesn't work so well for the large models. Sorry, the membership inference doesn't work so well for the language models. Basically here we need a certain number of data points to get that right. So what your task eventually will be, that we'll be providing you with 1,000 subsets of data and
1,000 subsets, yes.
And a machine learning model, and you will be able to query our model, and with that you will assign continuous membership scores to each of the subsets. The scores range from 0 to 1, where 0 means you're very confident that this particular subset was not used in training, and 1 means you're very confident that the subset was used in training. And you will be assigning those to the data points, to the data subsets, and then we'll be calculating the true positive rate at a 5% false positive rate. So we will also share those slides with you, so you can revisit all the metrics and just understand what they mean more in detail. But overall, what you want to be doing is that you want to be kind of conservatively predicting without overly being positive, and just try to get a high fidelity and accurate score that depicts whether the subset was used in training or not. Mm-hmm. And okay, we have a short example for the formatting. It's probably best for you to look at then once you're working on it, but you'll be given the subset IDs, and then you'll just be returning a file where the second column is the score.
Okay, perfect. So now we can move to the task 2, which is about text attribution. It's actually task was contributed by Advik. So Advik is here with us. If he wave, okay, you can see Advik is there. So if you have any questions, detailed questions, you can also go to Advik or ask any one of us, but actually Advik was contributing exactly this task. So let me first give you a brief overview of what currently language models look like. So they follow this paradigm of predicting the next token. So if you, for example, have this sentence, she ate N, then the model is provided with this prefix, and the model is supposed to generate the suffix, in this case being a word or a token apple. Here also have the factorization of the probability, how we really take the probabilities per a given token. So why do we really operate in this paradigm of predicting the next token? There are many benefits of that. First of all, as probably most of you heard about, we have scaling clause. So it occurs that if you provide more data, you have a bigger model, and also you provide more compute, and actually you can improve this model's performance. And second thing is that even without training these models on a specific task, you can still perform well and generalize to many unseen tasks with these models. So this is really thanks to training these models with this large data, with this next token prediction. Now, the question is, if you have a given piece of text, then how can we really attribute, how can we really find what is the source of this text generation? So which of these models, or maybe a human being, generated a given text? So your task in this second part is to match a source. So you are given a piece of text, and you have to find out which of the, in this case, 13 sources is responsible for the given text. To be precise, these are these 13 sources. So you have from 1 to 11 different large language models, and the 12th class is a human being. So this, as Franziska mentioned, one of these texts might come from a human being. And then the 13th class is an outlier, meaning that potentially a model that is actually not in this list from 1 to 11. So your task is for each of these pieces of text to classify which of these classes was generating the text. Now, let me give you an overview of what we provide in this task. So the first thing is that we provide data set, which is created by Advik. We have more than 83,000 texts. And then this is this CSV file that actually is provided also to you by Hugging Face, also on the cluster, participants_train.csv. It has 5 columns. So the model, which generates a given piece of text, temperature used for the generation, and also top P parameter for the generation, domain, for example, from which kind of domain the text comes from, can be general writing, like in the first example, or for example, a piece of code. And finally, the response, meaning the text that actually was by the given model generated. So this is the first piece of data that we provide to you. Second one is this, I call it unlabeled, but basically we have 20,000+ of texts, which is in participants_test.csv file. It has 2 columns. So have UUID, so basically universal ID for the given piece of text, and then the response, so the original text that we want you to find out which model or which class it came from. So finally, what you have to provide for the submission is the following file, can be called submission.csv, but basically you have to provide these 2 columns, UUID, so ID of the given text, and the model, so your guessed class or inferred class from which this text comes from. Now, what are the metrics that we use for this task? So again, here first one is precision. So we focus on what we classified. So this is number of true positives versus all the true positive plus false positives. Second is recall. So we focus on this positive samples. So it's true positive over all positive samples, also true positive rate. And now the main score for this task is F1 score. Probably most of you heard about that, but just a reminder, it's just the harmonic mean between precision and recall. And we have basically added this formulation, how we can define this F1 score in different ways. So what is here important is that we consider these 13 classes, and then for each of these classes, we compute F1 score. And the final score on the leaderboard for this task is a macro F1 score, which is basically arithmetic mean of each of these F1 scores per class. So what's really important here is that we consider actually each class to be equally important. So even though we have many more samples from a given class, we still compute this F1 score per class and arithmetic mean across these 13 classes. Okay, any questions regarding the task 2? Okay, go ahead.
We will get the slides, right?
Yes, so I will send them on Discord. Okay, Perfect. So apart from these main scores, you might also consider computing other scores. For example, one of them is per-cost accuracy. So you just compute number of correct predictions versus all the predictions, like basic stuff. Also, what people usually do for this kind of tasks with different number of samples per class is AUC score. So just to give you some overview of that, so you have basically AUC score. You have this graph with the TPR on the y-axis, and the x-axis is FPR, and the perfect AUC score equals 1.0, which is this basically that even at the 0 FPR, you get perfect TPR. Now, if your AUC score is 0.5, you have basically this diagonal over this graph, then actually you have a random classifier, meaning that your solution or our solution is not really performing at all well. And what is really the goal is that if you compute this TPR versus FPR, this basically ROC curve should be as high as possible, so as close to this step function for AUC equals 1.0. Okay, so now let's move on to task 3, which is about watermarking. So the task here is to remove a watermark. So we give you a lot of images with, which are watermarked, and then you will act as an attacker to remove this watermark. So for this task, we have Maitri, who worked mostly on this task. Maitri can also wave her hand. So it's Maitri, there is also Shun and Vincent. So these 3 people in the last row, they also know all the details about this task. So how this really works? So in general, if we give you an image, you might have some detector to find out if the given image actually was or not watermarked. Actually, it's a hard problem. So how it really works is that we, from the generation, we also, during generation process actually, we add watermark. So we make the image to be specifically generated to mark it so that later on we can actually infer that the given actually image was not natural but was generated. So let me give you introduction a bit to how currently actually we generate images. So we actually moved to generating images also in this fashion of predicting the next token. So here what you see is that you start from the very blurred part. So this R1 is resolution 1. So you have blurred understanding of what the image would look like. And then you predict the next resolution, R sub 2, R sub 3, and so on and so forth. In each actually of these resolutions, you have many tokens. And finally, at R sub k, you have all the details of the given image. So this is currently how we autoregressively, so token by token, predict these images. Now, what's more is that it was even moved further in the research area from next token to next bit. So there is a model that actually achieves now state-of-the-art in the generating of images, which is called bit infinity, which is bitwise watermarking, bitwise generation. So in each scale, or R sub 1, R sub 2, R sub 3, you actually express this given resolution as bits. So you predict essentially in this model the next bit. Now, what is really the point is that we would like to nudge the model to generate specifically more of these green sequences of bits. So let me explain it more. So imagine that you have this generating of the images bit by bit, and now the model generates bit 1. Next, we define that in these generations, we have a red list of bits and also green list of bits. So we have these bits 0, 1, 1.0, 1, 0, being that we don't want to generate these bits of sequences. And also we have the green list. So these are bits 1, 1 and 0, 0 that actually we want to generate. So imagine that we want this green list to be generated. So we have from the model now generated bit 1. So if you would guess which bit should we nudge the model, should we encourage the model to generate? Should it be bit 0 or bit 1? Any guesses?
Bit 1.
Very good, very good. So we want indeed to follow this generation with the green list. And after bit 1, we want to generate also bit 1 so that we can complete the first sequence of the green bits, bits 1, 1. Thank you. So how do we really generate these bits? So actually for each bit, we have the probability of predicting bit 1 versus bit 0. This is probability of predicting bit 1. So we have the logits L sub 1, L sub 0. We compute the softmax and the corresponding probability for the generation of the bit 0. Now, how do we really force the model, or I call it nudge the model, to generate the green bit sequences? Is that we add this parameter delta to the specific logits for the green bits. So L sub 1, we add this delta to just nudge the model to generate these green sequences of bits. Now, so once we generate this image, how do we find out if the image actually was watermarked or not? So we take into account the fact that, okay, a given image is not watermarked. And then this is our new hypothesis. And we want to find out if this is the case or not. So what we really compute is that we count how many of these bits are green from these green sequences, how many of them are from the red sequences, and then we compute the z-score. So actually here you have C. This upper C actually is the actual number of bits that are green. And also we have this expectation of green bits and red bits. And this actually allows us to compute this z-score. Okay, so your task is this. We give you these 100 images that are watermarked, and then you have to design attack or attacks that actually can remove this watermark from the given image. However, there is a constraint. So the constraint is that you should remove the watermark, but not to destroy the image. So we then measure also what is your attacked image versus the original one. So how much we modified the image to remove the watermark. So here we compute this mean squared error distance, MSE, and we really want you to preserve the high image quality. So the image that you attack should be as close as possible to the original image. And your aim should be that this MSE should be less than equal, actually 0.08 with current setup. So your submission file is as follows. You give us the images that you attacked. So these are in this numpar array. So this is the specific format, and also the names, so the initial names of these images. And then we evaluate how you performed in removing this watermark from the images. Okay.
Any questions? This was basically everything about the tasks that we have for the hackathon. And now is time if you have any questions before.
Do these submission files for task 1 and task 2 have like a specific name they have to be, or can we name them? Because for task 3 we need a specific name, submission and easy.
So you basically, like, the file doesn't need to be named specifically, but we showed you that these tables, like your submission needs to have the UUIDs for the text, and it needs to have the subset ID for, like, with the corresponding score. But the file name there doesn't matter.
Mm-hmm.
Go ahead.
The task has to be done like 1, 2, 3, or can we just start whatever we like?
So usually what we would recommend, like, I mean, eventually the team average will be calculated as the scores over all the tasks. So what we usually have seen as a successful strategy is that you kind of divide and conquer, so that you try to have a solution at least for everything. And then basically, like, maybe some people can specialize and then in parallel pursue the tasks. What I would, like, you can also, of course, go sequentially if you think that works better for your team. But I think what you need to make sure is that you have, like, a reasonable solution for all the tasks. Because let's say your team, like, number 1 in 2 tasks, but then you didn't solve the 3rd task. So you'll be the last score there, basically. So on average, you still won't rank very well. So it's up to you how to do it eventually, but that's the recommendation.
I would have a few more. Like, how many submissions can I submit? Is it like there's a limit, or?
Yes, so there's actually a limit. So we throttle the API, meaning that after a submission, there might be some cooldown. Usually it's, as of now, I think 5 minutes, what we said. So it's also, like, once you start submitting the solutions, also we provide the sample submission file, so you can run that, and then you will also see how much timeout we have after each submission. But there is a timeout, yes. Okay, so in half an hour actually went through the main tasks.
Exactly.
Also, I think that what would be useful for you is to know about GPUs. So these tasks are compute heavy. So it'd be great if you could also leverage what we provide to you, meaning this infrastructure. with GPUs. So, thanks to Julius, which is Computer Center in Germany, we have plenty of resources. So we have these compute nodes. On each of them, you have 4 times 800 GPUs. Also, you usually log into the login nodes. There are smaller GPUs that you can also use to just develop your tasks. Now, probably most of you went through that, but please, if you are still not registered, please register at Julius. Then you have to also set up your MFA. So usually it's through, for example, like free OTP or authenticator from Google. So any tool you like. Next, you have to also sign this user agreement. So this is something that we would like you to also do, to work on the tasks, not to, for example, mine a Bitcoin. Then you also have to use the SSH keys. So to access the server, either you use your current SSH keys or generate a new ones. So this is a kind of recipe how to do it. And then once you have the SSH key, you just have to copy that to this specific field for the given project. Also, there is something like a requirement for the IP addresses. Please just copy that from this field above and have this arrow to this lower field. So just copy these IP addresses and you would be fine. Now, it might be also that here after you do all of these steps, there might be some timeout. So you might have to wait a couple of minutes, up to 15 minutes, to get every data up to date on the servers. Then actually you can use your SSH keys and then your login that you chose or Julius chose for you, and you can just SSH into the login node. Now, what we usually observe is that most of us like using either VS Code or similar tools. I think most of us use VS Code, so we just have this intro to how to use VS Code for this task development. So once you open VS Code, just click into this bottom left corner, and then you would be guided to connect through VS Code to the server through SSH. So then basically you just select configuration, so SSH host that you would like to connect to. This should be Julius, and I will show you how to set up this Julius. So you just go to this .sh config. This is on Mac, but this looks similar usually on other platforms, being Linux or Windows. And here basically we figure out that you have to just set up, basically copy this to your .ssh config file. So your host should be Julius, host name the same, username changed to your username, and also the file basically is SSH private key. And this is the path to this private key, and also for especially Windows users, also use this last value for max. Now, once you set this up, you just go again to this SSH, and then you basically choose the Julius to connect to Julius on VS Code. Okay, then you basically choose new terminal, and you are there. So basically, you can now access Julius through the VS Code in this terminal. So also, I think some of you already posted. This should be 2556, I think, as of now. Okay, I will just update that and send this to Discord. So this is basically initial setup for you to start coding. And you can also actually use our hackathon.git. So please clone this repository, and also over there you can actually find all the info about the tasks. I think the best as of now is to copy the tasks from the Julius server. Okay. And also we provide sample submissions, so you basically can see how to submit the file. So for example, there's questions regarding like if there's any throttling or any other aspects. So you can also find it out in these sample submission files. Now, this is also important. We will provide you very soon with the tokens. So actually each team will have a specific token to submit the tasks. So then you replace this API underscore key with your given token. And what we also recommend is that using UV, so some of us used to use Conda in the past, but what we observe actually is that much faster development happens if you use UV. So we recommend using this tool. Now, you have to also configure UV. This is just easy. Copy that to your bash rc file. You can just also do that from this. I think this is easier to copy, by the way. And then you also have additional commands. They have to just basically type in the terminal, and you very fast figure out how to use that. So what we really recommend is this. So once you have your task developed, you check that how it works on the login node, then your friend is sbatch. So you create this sbatch script. You can just copy also that. You only change this sample submission. You can have your main.py, your other file. So the file where you have your solution. And actually this allows you really to use this powerful compute node with 800 GPUs. There is one more thing is that once you create this sbatch file, you just go to the terminal, you type sbatch main.py, and you can just run this sbatch script. Additional thing is that it's also compute nodes have 400 GPUs. There's also a command actually that you can use all the GPUs at the same time. So there is something like srun, at the end you add the ampersand to be able to have 4 different jobs on each GPU separately. This allows you to use the resources efficiently and maximize your, I think, final score. So, any questions regarding infrastructure, GPUs, or the tasks? Okay, I think that probably, okay.
Even,
You said there would be task Git repo or something to pull. Where do we do that?
Yeah, so I think we provide it very soon on Discord. So everything will be sent over there.
and then the last question from us to you: is there still any single participant teams around? Okay, perfect. Is there any team that has like 2 or so participants and would like to have an additional member? Then like please merge. I think the tasks are so big that if you're just 2 people, I think you will have a hard time against the teams where like there are at least as many people as tasks. So I think like please reach out to each other and then come see me and let me know about the team merging basically, such that I can generate the API tokens accordingly. And like, is there already a team that is looking for another member? Okay, awesome. Okay. Sorry to hear that, but I think you might make a good match then, at least for now. Awesome. So like maybe come and see me afterwards and just let me know under which team name you'll be competing. And then like in the next 15 minutes, we'll dispatch the API tokens confidentially to each of you via email. And there is a token per team. And basically this token then like gives you the access to the API. Yeah.
Mm-hmm. Okay, so also that will be also the labels for the teams, right, in the rooms.
And yes, like each team is going to get a number, and we're going to display that on a slide here, which team is going to be assigned to which rooms. We have the seminar rooms like number 1 to 6, and you'll be seeing in which room your team is seated in a second.
What about the task IDs? Because we also need them in the submission file. Do we get the task IDs as well?
So basically, how it works is that we have API, and in API actually, in API URL actually there is a task ID. And actually, you submit your task with your specific token to this IP, to this API. So the token works for each of these tasks, and you actually have different URL to each of the tasks. So
this string, we need to access like the individual tasks. Do we get like the ID for each task token that we can plug this into our script? We're gonna make a request to like a different URL each time, right?
yes, yes,
Slash submit slash every task ID.
yes,
So we need this task ID, right?
yes.
Will we be provided?
Yes, 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 yes. We will send very soon the, I think, all the docs for each task on Discord. To be probably over there already now. Okay, so let me just check.
Gerne auch als Screenshot einfach